Imagine for a second a company spending just, millions of dollars to turn their corporate headquarters into this high-tech fortress.
Right, like the full 9 yards.
Exactly. We're talking biometric locks,
Yeah.
armed guards, iris scanners, the works. But then they get robbed blind by someone who just walks up to the valet stand, asks for the keys to the vault, and calmly drives away.
Yeah, no hacking required, really.
Right. And when you picture a modern cyber attack, it is so easy to imagine that cinematic hacking, right? Like shadowy figures in dark hoodies furiously typing complex code to smash through those high-tech firewalls.
Oh, absolutely, the Hollywood version.
Yeah. But the reality of our digital landscape right now, as of today, July 14, 2026, is a lot less cinematic and, frankly, a lot more unsettling. Attackers aren't necessarily trying to break down your massive defensive walls anymore. They are weaponizing the things you already trust.
And that's because the mentality of the modern threat actor has fundamentally shifted. I mean, finding a novel, incredibly complex way into a network is, well, it's exhausting. It's expensive, and it alerts security teams.
Which is exactly what they don't want.
Right, so the most sophisticated actors out there are looking for the path of absolute least resistance. And what we're seeing across the board is that this path is paved with our own digital clutter.
Our own mess, basically.
Exactly. It's the forgotten hardware gathering dust in a server room, or, the seemingly innocent browser tabs left open on a laptop, and even the legitimate, approved business apps we rely on every single day.
And that is exactly what we are unpacking in this deep dive.
Yeah.
Because if you look at the major security reports that just dropped, this really clear, chilling pattern emerges about how this path of least resistance is being exploited.
It's a very clear trend.
So let's start with what happens when governments try to shut down the traditional cybercrime avenues. Because the U.S. Treasury Department's Office of Foreign Assets Control, OFAC, they just dropped the hammer on a VPN provider called First VPN Service, usually known as 1VPNs.
Yeah, and we should clarify, this wasn't your standard consumer VPN for, watching out-of-market sports or whatever.
No, definitely not.
Far from it. 1VPNs and its Ukrainian administrator, Dmytro Reshevsky, have essentially operated as a bulletproof safe haven for ransomware groups since around 2014.
Wow, so over a decade.
Yeah. They explicitly marketed themselves as a no-log service that would never, ever cooperate with law enforcement. Reshevsky even used aliases like Maxim Sorin and Roman Chabanenko just to purchase server space from legitimate hosting companies, because otherwise those companies would have blacklisted him due to abuse complaints.
Right, because of all the shady traffic. And he wasn't sanctioned alone either. The U.S. also went after a Belarusian national named Yevgeny Vladimirovich Sileyev, who is a vendor selling malware cryptors.
Yes, the cryptors are a crucial piece of this puzzle.
So if we translate this out of cybersecurity jargon and look at a ransomware attack like a digital bank robbery, the ransomware operators are the thieves inside the vault. But 1VPNs is the guy providing the untraceable, unmarked getaway cars.
I like that analogy.
And then Sileyev selling these cryptors, which, scramble the malicious code so security tools think it's just a normal, safe program.
Yeah.
He is the guy selling the fake mustaches and the security guard uniforms.
That analogy holds up perfectly, actually. Law enforcement agencies are realizing that playing whack-a-mole with individual ransomware gangs is just a losing battle.
It's endless.
Right. So the strategy now is to disrupt the entire business model. You take away the getaway drivers and the disguise vendors, and the robberies become exponentially harder to execute. And you see this echoed in Europe as well right now.
Oh, right. The UK and EU sanctions.
Exactly. They just concurrently sanctioned 24 Russian individuals and entities, including some serious state-sponsored heavy hitters like GR Unit 29155 and FSB Center 16.
It's Center 16, yeah. That's the group linked to the disruptive sabotage operations against Poland's energy grid late last year, right?
That's the one.
So the West is aggressively targeting the infrastructure and the facilitators of these state-sponsored groups. And here's the detail that absolutely floored me when I was reading the prep for this.
The router thing.
The router thing. Right as these sanctions are announced, the FBI issues a new advisory about how FSB Center 16 is actually getting into critical infrastructure. And you would think these elite intelligence operatives are using the most advanced futuristic exploits known to man, right?
You'd assume so, yeah.
Instead, they're looking for old Cisco routers. And not just slightly old routers. The FBI advisory explicitly points out that they are exploiting poorly configured networking devices using incredibly dated vulnerabilities. One of them is CDE 2018-0171, which is from 2018.
Which is pretty bad on its own.
which is bad enough.
Ah.
But the other one they highlighted is CVE 2008-4128. That is from 2008. That is the year the first iPhone 3G was released.
It is wild to think about.
I genuinely struggle to comprehend this. How on earth are elite, state-sponsored hackers successfully breaching critical infrastructure worldwide using a vulnerability that is practically old enough to vote?
Well, it comes back to the sheer economics of cyber espionage. I mean, the general public assumes state actors rely entirely on million-dollar, zero-day exploits. You know, those vulnerabilities nobody knows about yet.
Like the really flashy stuff.
Right. And they certainly have those in their arsenal. But why burn a highly valuable million-dollar, zero-day tool that will be patched the second it gets discovered when you can just use a known bug from 2008 that works perfectly fine?
Because someone, somewhere, just forgot to update their hardware.
Exactly. The mechanism they're using here is actually remarkably simple, which is what makes it so effective. The attackers scan the internet looking for devices running an active, simple network management protocol, or SNMP agent.
Yeah, SNMP.
Yeah, it's a very old protocol used for managing devices on a network. If they find a router using a default password or incredibly weak authentication, they spoof an IP address to make it look like they are an authorized user on the network. Then they send an SNMP set request.
So it's essentially like they find an open window, reach in with universal remote control, and just change the channel on your TV.
Yes, but in this case, the channel change is an instruction telling the router to copy its entire configuration file, which contains passwords, network maps, everything, and quietly hand it over to a server controlled by the attacker.
Wow.
They don't need to break down your defensive wall. They just walk through the rusted-out back gate that was installed 18 years ago and never maintained.
It makes you wonder how a 2008 router even survives in a corporate network today. I have to imagine it's the result of like corporate mergers, right?
Mm-hmm.
Where a company buys another company, inherits their IT closet, and some router is just physically buried behind drywall in a basement somewhere.
Just quietly humming away.
Yeah, completely forgotten by the current IT staff.
It happens all the time. The U.S. Cybersecurity and Infrastructure Security Agency actually had to add that 2008 vulnerability to their known exploited vulnerabilities catalog just this week.
Like just now.
Just now, legally mandating federal agencies to fix it. It is a stark reminder that legacy infrastructure is a total goldmine for attackers.
Okay, so if leaving a physical router unpatched for 18 years is the lazy, low-resistance way for state actors to get in, it begs the question of what happens when a completely different breed of attacker decides they don't even want to go looking for your old hardware.
Right.
What if they just decide to weaponize the hardware sitting on your desk right now?
Well, then you get the situation JFrog just uncovered on the NPM registry. This is a massive shift in tactics.
Let's set the stage for this, because this campaign is wild. JFrog, the software supply chain security company, found 148 malicious packages on NPM. Now, NPM is a public registry where software developers share JavaScript code.
Standard stuff for developers.
Right. Usually a supply chain attack here looks like what we saw with the ShinyHunters worm last September. An attacker poisons a code package, a developer downloads it to build an app, and the malicious code executes during the installation, stealing the developer's passwords or access tokens.
That is the traditional model. You compromise the developer to compromise the software. But this campaign bypassed the developer entirely.
The first clue was the names of the packages, right? Because they weren't trying to look like legitimate coding tools. They had juvenile names like Charlie Kirk or I Love Femboys.
Yeah, very internet culture, heavily skewed.
Exactly. And they were disguised as web proxy applications, branded under names like Lucide or Riverbend Tutoring. They were targeting high school and college students.
Because students are always looking for ways to bypass their school's web content filters. They want to play games, watch YouTube, or browse sites that the campus IT department has blocked.
Naturally.
Right, so a student searches for an unblocked proxy, finds one of these sites hosted on NPM, and opens it in their browser tab.
And on the surface, it works. The student gets to play their Flash games or browse the web. They think they're pulling a fast one on the school administrators, but they're actually just being farmed for their bandwidth.
Exactly. JFrog deobfuscated the underlying code and found something incredibly sophisticated running silently in the background before the proxy interface even loaded on the screen.
It's like the Matrix. They think they're having fun, but they're just human batteries for this invisible machine.
That's actually a great way to put it. There were two distinct YAC modules. The first one, designated module G2, functioned as a remote script loader.
Which means it's reaching out to the internet to get its actual instructions, rather than keeping the malicious code inside the initial package.
Precisely. It silently pulled a malicious JavaScript payload from a GitHub repository and executed it using the full privileges of the proxy site the student had open. And in late May, the instruction from that GitHub repository was to launch a massive HTTP flood.
Now, an HTTP flood is a denial of service attack, right?
Yeah.
Flooding a target with junk traffic until it collapses.
Yes. Every 500 milliseconds, the student's browser would automatically generate a massive 1 million character text string and hurl it at the public domain of a nursing school in Illinois.
A nursing school? That's so random.
Completely random. And to do this without the browser's built-in security stopping it, the script used something called a no-cores request.
Okay, I'm trying to wrap my head around that. Usually, if my browser tries to send a massive data dump to a random website I haven't visited, the browser stops it, right? It checks the permissions.
Under normal circumstances, yes. Cross-origin resource sharing, or CORE, acts as a security checkpoint. If Site A tries to send data to Site B has to explicitly say it accepts that data.
Okay.
But a no-cores request is a loophole. It is essentially like sending 1 million heavy envelopes through the mail without a return address. The post office doesn't check where it came from. It just delivers the heavy envelopes, completely overwhelming the recipient's mailbox.
That is devious.
JFrog calculated that just 1,000 students leaving these proxy tabs open could bombard that nursing school with about 2 gigabytes of attack traffic every single second.
2 gigabytes a second from just 1,000 kids wanting to play Flash games. And that is just the first module. The second one, Module I2, didn't attack a nursing school. It went after other student proxy servers.
Yeah, this module was far more surgical. It abused a specific technology called the WISP WebSocket protocol. WISP is heavily used in these proxy communities because it is designed to tunnel lots of different web connections over a single socket, making it very efficient.
Okay, so if WISP is designed to be efficient, how do you weaponize it?
By doing the exact opposite. Module I2 instructed the unwitting student's browser to open up to 1,024 concurrent WebSocket connections against competing WISP proxy servers. This creates what we call a control plane attack.
A control plane attack, meaning it's not trying to overwhelm the server with raw data size like those heavy envelopes from earlier. It's attacking the server's ability to manage traffic.
Think of a server as a receptionist answering phones. Every time a browser connects, the server has to allocate a file descriptor, essentially. It has to dedicate one of its hands to hold that specific phone line open.
Got it.
The attacking browser rapidly sends a connect command and then immediately sends a close command over and over again, thousands of times a second.
So the receptionist is constantly picking up the phone, hearing a dial tone, hanging up, and instantly the phone rings again.
Eventually, the receptionist just collapses. The remote server exhausts its pool of file descriptors, its log storage fills up with error messages, and the entire proxy crashes. The attackers were weaponizing the infrastructure of students to systematically take down the infrastructure of competing proxies.
It's brilliantly diabolical. And yet, the breadcrumbs point to an operator who is probably very young. I mean, JFrog found comments left in the source code saying things like, "Tie waves plus ChatGPT Eiley."
Thank you, ChatGPT. I love you.
Yeah. They used an AI chatbot to help write a sophisticated browser botnet and then managed to push 116 of these malicious packages to the public NPM registry in under 35 minutes without tripping a single automated alarm.
And the evasion tactic here is what makes this a watershed moment for supply chain security.
Right.
Standard security tools and dependency scanners are designed to look for malicious code that attempts to execute when a package is installed by a developer.
But this code never asks to be installed.
Never. It just sits passively on the NPM registry. The attacker is essentially treating a massive enterprise-grade public registry as their own free content delivery network. The malicious activity only triggers when a human being, a student, loads the code into their live browser environment. It operates entirely outside the traditional build pipeline that we spend so much money defending.
Here's where it gets really interesting to me because it's terrifying. It bypasses the hard stuff entirely.
Yeah.
You don't need to hack a server if you can just trick a kid into opening a browser tab that turns their laptop into your weapon.
Exactly.
Which leads us to a very uncomfortable realization. It is one thing to weaponize a student's browser to bypass a high school firewall. But what happens when attackers apply this exact same philosophy of bypassing defenses to highly secure Fortune 500 corporate environments?
Then you get the ShinyHunters campaign against Salesforce.
Yes, Microsoft and Salesforce just published this massive joint report detailing a year-long campaign by this extortion group, ShinyHunters. They breached dozens of enterprise Salesforce environments. And the most shocking detail,
They didn't use a single exploit.
not one. They didn't write any zero-day code. They didn't even drop a single piece of malware.
Because they realized that dropping malware triggers endpoint detection systems. And writing exploits takes time. Instead, they exploited the trust that these organizations had already willingly extended, specifically by abusing OAuth connections.
Let's demystify oath real quick, because it is something we all use every single day without thinking about it. When you click a button that says log in with Google, or an app pops up asking, do you want to allow this application to access your calendar? And you click yes, that is OAuth in action.
It is the framework that allows different software platforms to talk to each other and share data without ever exposing your actual password.
Right.
When you click yes, a digital token is generated. That token is essentially a VIP backstage pass that the app can show to the server whenever it wants, proving it has your permission to be there.
So how do you abuse that? Microsoft mapped out 3 distinct paths ShinyHunters took over the past year. Path 1 sounds incredibly low-tech, but it clearly works phishing, or voice phishing.
Starting in mid-2025, the attackers simply picked up the phone. They called corporate employees, pretended to be from the internal IT support desk, and talked the employee through clicking approve on an OAuth consent screen.
But the app they were approving wasn't legitimate. The attackers just disguised their malicious app to look like Salesforce's real data loader tool.
The employee thinks, oh, IT just needs me to update the data loader, no problem, and clicks approve. The moment they do, the attacker's app is handed that VIP backstage pass. It now has persistent API access to the company's Salesforce records.
Just like that.
Just like that. Google's threat intelligence group actually noted this exact method was used to breach massive global brands recently. Chanel, Pandora, Adidas, Qantas, no malware required, just a confident phone call and a fake name on an app.
It is the valet key analogy perfectly. They literally just asked for the keys. But Path 2 is even more insidious, I think, because it bypasses the employee entirely. It relies on vendor compromise.
Yeah, if calling a user is too risky, the attackers found a quieter route. They targeted third-party software vendors whose apps already possessed trusted access to thousands of enterprise Salesforce customers. Like, in August 2025, they compromised an AI chat integration vendor called SalesLoft Drift.
So by breaking into Drift, they got access to Drift's VIP passes.
They stole the OAuth tokens that Drift legitimately held for its customers. The attackers then used those stolen tokens to silently query and export massive amounts of data from potentially hundreds of downstream organizations like Cloudflare and Palo Alto networks.
And it wasn't just Drift. They hit a customer success platform called Gainsight and a competitive intelligence platform called Clue. And the detail about Clue is just a nightmare for IT admins.
The legacy credential.
Yes. The attackers didn't even need to hack Clue's main production systems. They found a legacy test credential from an old integration experiment that was never even fully deployed. They used that forgotten, unmonitored test credential to get in and harvest tokens.
Which highlights the danger of digital clutter again. A forgotten test credential just left the door wide open, and that perfectly sets up Path 3, which didn't require any stolen credentials, no stolen tokens, and no phishing phone calls whatsoever.
Right.
It relied purely on misconfigured guest access.
Microsoft found attackers scanning Salesforce Aura endpoints, the underlying framework for what Salesforce calls experience cloud sites. These are often used for, customer portals or public help forums.
The attackers scanned these sites looking for instances where a company's administrators had accidentally granted overly broad permissions to the default guest user role. If the guest role had access to internal records, the attackers utilized a programming technique in GraphQL called cursor-based pagination.
This is where we need to translate the technical mechanics again, I think. What exactly is cursor-based pagination, and why is it so devastating when combined with guest access?
Okay, think of a massive corporate database, like a gigantic library. Normally, if you want a book, you go to the librarian, show your card, and ask for a specific title. Cursor-based pagination is a developer tool designed for efficiency. It allows an application to say to the librarian, give me book 1. Now keep your finger on that spot and just keep handing me the very next book on the shelf until the entire library is empty.
Wow. And because the guest access was misconfigured, nobody was checking the library card for every new book.
Exactly.
The attackers could just silently siphon massive amounts of data in a continuous stream without ever authenticating or logging in.
The telemetry of this is terrifying for a security operations center. The identity controls that corporations have spent the last decade and millions of dollars building, like multi-factor authentication, were designed entirely for human logins.
Right, checking human behavior.
Yeah, MFA is the bouncer at the front door checking human IDs. It does absolutely nothing to stop machine-to-machine OAuth abuse because OAuth is the VIP pass that lets the machine use the private backdoor.
If I'm a business owner, how am I supposed to catch this? If the access is coming from an app I officially approved or a vendor I signed a contract with, it just looks like normal background automation to my security software, right? It isn't going to trigger a failed login alert because the login didn't fail.
Standard authentication logs miss this completely because the application is technically allowed to be there. The paradigm has to shift from who is logging in to what is this app actually doing once it has access.
So how do they fix that?
Well, Microsoft eventually rolled out a specific fix for this in Defender for Cloud Apps. They had to upgrade the telemetry so security teams could attribute specific API calls to specific OAuth apps, finally allowing them to see if an app is suddenly downloading an unusually massive amount of data.
So the perimeter is no longer the firewall.
The modern perimeter is identity and permissions management. It is knowing exactly which apps and machines are connected to your environment, understanding what permissions they have, and rigorously, ruthlessly deleting the integrations and test credentials you no longer use.
It all comes back to a concept of digital hygiene, really. Whether we are talking about an outdated Cisco router from 2008 left running in a basement, a cached student proxy tab left open in a web browser, or a forgotten third-party app integration from a vendor in an enterprise Salesforce instance.
It's all connected by that theme.
Today's attackers aren't necessarily hacking your passwords, and they aren't burning zero-day exploits. They are hacking your trust, and they are hiding in your digital clutter.
Good security today is less about the expensive tools you buy to build a wall and more about what you actively choose to keep, what you choose to delete, and what you grant permission to in your daily digital life. Because if you leave things lying around unmonitored, someone will eventually find a way to weaponize them against you.
Which brings us to a final thought I want to leave you with today. We talked about how those DDoS modules in the student proxy botnet were designed to fetch their attack instructions from a mutable GitHub branch.
Right, Module G2.
Yeah. The operators don't even need to issue a software update. They can just change the code on GitHub, and every student's browser will instantly start executing the new attack. But think about the broader implications of that architecture.
It creates a really fascinating and complex web of attribution and responsibility.
Exactly. If a high school student uses a school-issued laptop on a school-provided Wi-Fi network to unknowingly power a botnet that takes down the critical infrastructure of an Illinois nursing school, who is legally responsible for the damages?
Is it the 15-year-old?
Right. Is it the 15-year-old who just wanted to play a flash game? Is it the school district for failing to secure their own hardware? Or is it the NPM registry for hosting the proxy in the first place? As these attacks utilize the path of least resistance by borrowing our infrastructure, the line of who is actually launching the attack becomes incredibly blurred. We'll leave you to ponder how the legal system is possibly going to handle that nightmare. Stay curious, check your permissions, and we'll see you next time on The Deep Dive.